because I want to share it later. These three kind of concepts, which is architecture mediates nature, models mediate representation, and urban acupuncture mediates transformation in cities. And I'll talk about what urban acupuncture means. And this is three topics central to my research about our relationship with nature as architects. For me, it starts with memory. Memory is what we draw on our experiences for everything that we do. So this is my dad teaching me how to drive the RV when I was a kid. And memory is important. This is a video of me unpacking my library when my wife and I moved in to a condo. We've actually since moved out of this place, but I built this shelving system and we're unpacking our library about the importance of organizing our information and organizing our set of knowledge that we carry with us in the world. So it's kind of a time lapse. I won't go through the entire thing. But what interests me about the relationship between, say, literature or writing and architecture is that there's a very rich territory that has at times become disconnected. And so we should always search for this kind of narrative sensibility, in my view. This is a Selectric typewriter, which, anybody know what a Selectric typewriter is? I bet Bo does. I know. It's a gigantic 40-pound machine that came out in the late 60s, the first version of it, and was made in the millions. It was before the computer was a popular tool, you had the Selectric.
So you have seen these, right?
This is the case of it over here. This is every part of the Selectric. There's something like 1,850 pieces of it. I forget the exact number.
That's revolutionized business in the United States.
So productivity, business, all kinds of things. And IBM was behind the Selectric. Another important thing to keep in mind in regards to the sense of our narrative sensibility is nature. So I've done some long distance hiking. This was on the Pacific Crest Trail in California. And understanding that the relationship between a landscape and our designs is critical. So walking through the wind farms. This is the route of that hike through California. This is the height of distance that I think it amounted to climbing out of the atmosphere in the amount of vertical distance traveled up mountains. I think I added it up here. So that's like the equivalent of hiking up to 80,000 feet. But a little bit about my background. I grew up in the suburbs. I grew up here in Phoenix, around 60th Street and Cactus. And when I got into school and learned about kind of urbanism, took some courses in city making and architecture, I started to learn about the history of the suburbs. So this is an artist, Robert Bechtel, who paints oil paintings based on photographs that look like photographs, but they're in fact paintings. And he paints these kind of nondescript scenes of what is the fabric of the city? How do we observe the city that we inhabit? A little bit more background. My favorite movie, The Boy with the Red Balloon. If you haven't seen The Red Balloon, it's a French film from the late 50s, I believe. I think it's 59 or 60. And it's about this inanimate object, the balloon, that follows this little boy around and their friends. And there's a whole dynamic that takes place between him as almost kind of this mime figure and the balloon. Very briefly, how to find the North Star, because I find that it to be important. If you can find the Big Dipper, you can find the North Star off the two top edge stars of the Big Dipper, so no matter the orientation, you will always be able to find the North Star. Why is that important? We'll get into it. These are the rules I use for teaching and learning. There are no dumb questions. Be curious, work hard, but be kind to yourself and others. So three kind of tenets that I use in my teaching. And then the idea that a theory always starts somewhere. So I wouldn't imagine that any of you say that you have a hard and fast, true theory of architecture. You might be insecure in saying that you have such a thing, but inside of you, each of that is that narrative sensibility that you develop. So each of us has a kind of theory already of architecture, is my argument. Back to the library. Wandering, again, back to hiking. This idea that we wander through a creative problem is important and interesting. Imagining, using our imagination, is central to design and central to being a creative person. So I like to collage photographs, different things I find. Travel is central to creativity as well. This is a Richard Serra sculpture in Switzerland I had the opportunity to visit. Noticing things, being very aware, the kind of tactile sensibility of noticing our environment is critical as designers as we kind of gather that information and knowledge and experience about the built environment. Just being able to pick out detail and say, oh, I wonder where that came from. I wonder when that was built. I wonder what material that is. And noticing those things in the environment. This is art at Phoenix Art Museum. An Ed Mell piece, who recently, I think 2 years ago, maybe passed away? Yeah. Was it about 2 years ago? 3 years ago? And he captures this spirit of the southwestern landscape, this unique landscape that we have here in Arizona. This was a project I was fortunate to work on with Architectural Resource Team, where we wanted to kind of do this marker of time in the space. So we're building a new studio that's actually LFA certified, and which is Living Futures. I don't know if you guys are aware of Living Futures, but it's another certification system for sustainable buildings that's more based on petals than it is on points. It's very interesting, kind of new system that's developed. And the idea was to make an oculus in this roof through this breezeway that would mark the passing of time through an ellipse of sunlight. So here's a kind of time lapse. And directly at solar noon, from equinox through the summer to equinox, there appears this kind of ellipse on the ground. And right about somewhere in there is solar noon. And we get these kind of refractions because of the aluminum skirt of the assembly. This is all it was really an aluminum kind of wrapped piece that I did use some grasshopper for. There's a section through the roof assembly and that piece letting sunlight through at different times of the day. So the more extreme angle is the equinox, and the more vertical angle is the summer solstice. There's Doug McCord. We're installing it in the roof assembly. There's also this notion that creativity implies balance. So balancing technique with poetic understanding. Again, that narrative sensibility that we develop for almost the mind of a writer, right? And when we're drawing a building, we're also writing in space, you could say, right? So use all the tools at your disposal to experiment is something I like to say. I bought an Axidraw machine, the little rubber ducky on there. He is the mascot. And I would experiment with digital drawing using the CNC drawing machine. This is a mode of representation. Some of that representation takes more abstract forms. And then this notion of travel, coming back to that again, listening to your friend that wants to travel the world is critical and interesting. This is my friend Vern and I, a much younger version of me, living in Buenos Aires for about a year, where we had the opportunity to work for a friend of ours and do art installations. This was an art installation of clothespins, all hanging in space. You can actually go up and touch it, and it's a tactile experience. It was called Tender. And so this notion that when we create something, it's interacted with by the world. It's not a static thing that's in the abstract space. It's a real thing. And the notion that we touch materials, that materials have tactility, is important and interesting. Built some furniture, a shelf that looks like a kind of tree, and getting into this notion of now a model. So the word model has multiple definitions, which I find interesting because one of my favorite words is the word manifold, which means multiple. So a model can be a miniature, it can be a design, a system of postulates. So a model could be this kind of abstract thing of an argument you're trying to make. It could be a model, right? An emulation, a version, a description or analogy, or an organism or an image. So a model is like a whole host of things. So when you're building a model, you're not just building a static object, you're building a view of the world in some way. This is a housing project I had the opportunity to design for New Orleans in my, I think, 4th year of my undergraduate after the Katrina hurricane in '05. Some work, models, representation, charcoal drawings, different things that interested me when I was in my undergraduate. Both to do with this kind of serialization of form, looking at things in a serial fashion in order to understand the kind of dynamism of it, but also just moments of shadow, moments of pause. Models can be taken on the road. So this was actually my first job in architecture, was for David Baker Architects in San Francisco. After I graduated from UC Berkeley, I got this job as a model maker for this architect. And they wanted to take this model to the client, and the project was in Virginia. Oh no, I'm sorry, was it South Carolina? I think it was South Carolina. And they had to carry this model on a plane, so the model inverted and folded out of this little case. So again, a model is more than one thing. Sometimes models are at an urban scale, practicing, assisting an architect in studying an urban form in a certain location. Sometimes a model is just an exploration for its own sake. I call these bug models. They're like little studies, right? Students have made tiny models during the pandemic so that they could carry them easily. The importance of forging friendships, I think, is critical. So this is the plant lab. This was a project that was inspired by a group of students that built another project that I can show. And we formed our own class. So this notion also in academia that we have to go through the system and, okay, we take one class after another. As students, you have this kind of power, if you can find funding somewhere sometimes, to invent your own coursework at times. So we took this on ourselves. We wanted to investigate what is a hydroponic system of growing an indoor food production system. So this was the plant lab, and it grew 485, I think it was, individual heads of lettuce in a kind of artificial grasshopper landscape with this circulating water system that circulated water through it. Everything from the metal frames holding it up, everything was done in about 4 months by a group of 15 students, including myself. So this notion of a modular food system, we were interested in this kind of representational capacity of this project, which was a little surreal because it was at the San Francisco Flower and Garden Show, which, if you've never been to it, is in San Mateo, and it's a lot of homeowners looking at bird baths and kind of landscape architects and things, and this was like this alien object that like landed in the show, and so it was a very unique, interesting experience. Some more shots. I think these were all taken on film. This is the first project that preceded that with the same team, of a bench that we created, and this importance of drawing. Talking about, again, about that narrative sensibility that we develop. Developing that same sensibility by hand in drawing. So this is an inverted image of a chalkboard we used over the course of an afternoon to figure out how are we going to approach fabricating a bench that we had this very small budget to build. This is the evolution of the bench form, which started as a kind of reclined form, and we decided to break it up into multiple pieces and explore this kind of folding operation. And to me, this type of design is bridging an interest between material sensibility, fabrication, and architecture in a way that it's an occupiable, kind of large piece of furniture. There's the assembly, so there's two back-to-back steel angles that form the central structure. There's concrete foundation stem walls, and then the upcycled redwood that came from a local redwood supplier that had been, these trees had been like attacked by beetles and had to be cut down, so we upcycled the wood. Again, getting into the sensibility for shop drawings. If anybody knows about shop drawings, once you are building a building, there's specific elements of that building like stairs or sometimes windows and things like that that require another level of detail. They'll create what's called shop drawings, which generates the structure, which then generates the project. It's a social space. It's kind of used for the happy hours. It's still there on the UC Berkeley campus. Another tenet is to work hard. This was the hardest work I'd ever done in my career, I think, for a design build architect here in the Valley. Once you're on a job site, if you ever have the opportunity to visit a job site, for example, always take the opportunity. You'll learn so much. You'll see a lot of details coming together, material systems, the reality of building. You'll learn a ton just from visiting a job site. I was working as an assistant superintendent, figuring out, for instance, how these curtain wall columns, the window wall itself, are going to meet each truss. The truss package, every single truss in the building was unique. There was 268 of them. I worked with the truss manufacturer to get their 3D model and bring it into the Revit model and coordinate all these details. Huge learning experience. We also created these channelized systems in the ceiling. This all gets covered in this lath wood eventually, but the trusses are exposed. And you see this kind of channel. And within each channel is sprinkler openings, light openings, and air delivery. So all those details are carried by that channel. Some of the work is not glamorous. I'm driving the water truck. I'm having to keep the dirt wet and thinking to myself, I have a master's degree. Why am I watering dirt? But kind of, it's a degree of humility. It's actually really interesting in learning about how a construction site works as well. Some shots of the interior. This is the reflected ceiling plan of that ceiling, and this is the shop drawing I used to locate everything, every feature in the ceiling. And in developing this drawing, which took me about 3 weeks just in and of itself, during construction, which they need this information, there's an urgency, right, in the construction process, we had to label every piece, every element, and then it had to be digitally fabricated. It's also important to learn from failure. Not everything you're going to do as an architect is successful. So this is an example of me playing around in Grasshopper or something, trying to make a shelving system. It didn't work. Oh, it's kind of beautiful. Take a screenshot, right? Learning about architecture, about how details come together. This is for a greenhouse on top of a residence. So once you really start getting into detailing, into drawing using BIM or another program, you learn about that level of what's called level of detail, how things are represented in reality for the contractor and the subcontractors to understand how it comes together. This was the first project I ever drew in Revit that I was solely responsible for being the BIM leader on the project. This is a visualization packet that I also put together. Renderings of the house, which is just completed construction up in Paradise Valley. Some more shots of the house. And then this notion of experimentation, which is what we're going to get into next. This is another kind of Grasshopper research project done with Claudio Vekstein and the Indigenous Design Collaborative for an art installation that was going to take place in this kind of museum space, and they wanted an exhibition kind of pod to exhibit artwork. This is the first project I ever drew in Grasshopper, which is a shade pavilion. Every element of it, from the structure to the wood slats to the skirt of metal at the top, was all done with parametric software. Some speculative work. This was a project for UC Berkeley, my alma mater, where I went to grad school. And this is student life space study for the campus. So they are expanding student life space, buildings that aren't academic, where students use, like the Memorial Union or any number of spaces that students use, that you guys use every day, that you maybe don't notice that, hey, someone had to design that, right? So how do you fit something into a campus? Sketching early, figuring things out, from diagram to sketch. Lots of sketching. Diagramming over 3D models, some mixing media between a physical process and a digital process can be really fruitful. This is the campus plan. The kind of final renderings of the project, which was the student center. This is the Sproul Plaza, where lots of student protests took place, like back in the 60s. It's a very important kind of social space. And this is the entrance to the campus. I had another small opportunity to use some Grasshopper on some shading elements and things like that. And working now I'm interested in this kind of idea of optimization, which I understand that your class is also looking at kind of energy modeling and that kind of thing. So Picasso said, to know what to draw, one must begin drawing. So let's jump into a little bit of Grasshopper. So Grasshopper is an interface that links with Rhino. Everyone used Rhino before? Probably the majority of you. And you can, for lack of a better term, you can think of every command that happens in Rhino, for example, drawing a cube or a line or a point, as having an interface in here that can reference that geometry. So I'm going to make what's called a brep, which is just a 3D volume of space in Grasshopper. That's known as a brep. And I would just double click into the Grasshopper space, say, hey, I want to reference an object, right click, set one brep. Now Grasshopper knows that that object is that volume. And information flows in Grasshopper from left to right. Unless you have a very disorganized script, you want information to flow from left to right. And so the idea being that you can do any number of operations you can imagine on this geometry, really. So let's just say we want to array the geometry in kind of a volumetric fashion. So it's asking me for a number of inputs. Just like a command in Rhino, if I wanted to say array in Rhino, what's it going to ask me? Select the objects to array. Tell me what object, right? It's doing all those same things, but just in a kind of graphical node-based interface. It's asking for the geometry. It's asking for the cell by which, or the spacing by which that geometry will be multiplied. It's asking for X, Y, and Z. How many of those objects will there be, right? So I can give it these inputs. I can tell it, well, this is the geometry. I'm going to connect that little node like that. It's going to immediately have some default values in here, so you'll start to see something happening that isn't maybe what we intended, but we can say, all right, that cell is going to be set one box. I'm just going to define a kind of very loose form like this. And then I'll double click and enter a couple values. If I type in the number 13, it's going to create a number slider. I'm going to copy that a couple times and provide that information to this node. So X, Y, and Z, that becomes the number of elements in the array. So there's a whole array of objects, right? Now this is how Grasshopper thinks, is using digital information, inputs and outputs, essentially. And that's all you're really seeing in a Grasshopper script. When you open a Grasshopper script, or when you kind of get lost in one, it can look very complicated. You can have kind of memory problems about what was I doing here, and what was the mode I was in when I was trying to solve this, what was my state of mind. But getting into this space allows you to do some things, automate some things that might be repetitive otherwise, and give you kind of an advantage in that way. Now, to go a little bit further than this, let's just say we want to, for some reason, let's reduce the number of these. The cell.
Yeah.
Yes, the cell is essentially if I hover over any of these, it'll tell me the cell is a 3D box array.
Mm-hmm.
So the cell is another volume of space that's defined as two opposing 3D points.
So you didn't need to indicate that to make that array?
I could use geometry here. I could type in geometry. I could set a physical object in Rhino as that input. But what I did instead, I'm sorry if I didn't explain that, I right-clicked on that input and said, I'm just going to set one spacing or set one box. So if I change that now to a much larger area, for example, those are going to space way out because that's just the input for spacing. Got it? So one thing that's a new tool that's come along, and I know people have opinions about AI and energy use concerns, and those are all very real things. But AI is also useful for helping us problem solve. So I'm going to show you a tool called Raven. There's a student version of Raven that's, I think, $5 or $10 a month. It's $50 for the pro version otherwise, so it's a pretty good deal if you're a student. And once you install Raven, it appears as a button down here on the lower right. And let's imagine, I'm going to actually reset this cell to a smaller spacing so we can kind of see what we're doing. And let's imagine, for some odd reason, we want to rotate these cubes in some fashion. Now, I don't have enough Grasshopper knowledge to do that. I don't know how to do that. I'm going to use Raven to help me do it. So Raven's a wonderful way to learn some Grasshopper. Raven opens as this dialog window that actually stays on top of your desktop no matter what you're kind of doing. So if I open Rhino or Grasshopper, this stays on top, they're still working on this tool. It's in its first version. But within Raven, I can use language, back to the narrative sensibility, right? I can use actual language to tell Grasshopper to write me something, which is pretty impressive. It doesn't mean you don't learn Grasshopper, right? It's not a workaround to some deliverable. It's really part of a window into a process by which you can learn more of this kind of workflow. So let's say I want to randomly rotate these cubes. I can prompt Raven just very basically using the vrep input, rotate the cubes about their center randomly. Okay? Now, when I write a sentence like this, it's essentially a mini Grasshopper script, if you really think about it. I'm saying do this over here and then that, right? So now I'm going to hit enter. I'm going to put it, there's fast mode and smart mode. I'm going to put it in smart mode. There's also ask mode where you can ask it questions about a script. It won't edit it. It'll just tell you what's happening in the script, which is pretty interesting. So I'm going to hit enter and just see what it does. We'll zoom out a little bit here. It's going to think for about a minute. Usually it's under a minute, and depending on which settings you have and things like that. But it thinks about, it's going to start thinking about component search. It's going to look for a list of components related to my prompt, and it's going to start to put those in the space of Grasshopper and connect them based on its knowledge of how they should connect. And it's a recursive process, which is related to design. We don't design something in one pass, right? We design things iteratively. This is an iterative process. So we're going to see what it thinks. Still thinking. Are there any questions as while this thinks? Yeah.
What's the difference between fast and smart mode?
Just speed, really. I think it's smart mode will look more specifically at your language structure, I think, in some ways. Fast is more about a quick result. If you're using the fast mode to do something very simple, it's probably good, like arraying a grid, or even this, what we're doing right now, is relatively straightforward. You could probably use fast mode.
And you clicked smart, though.
I did click smart, because I'd rather it get it right.
Yeah.
And so, you know, the idea, though, that this idea of speed in the design process is like its own topic and time.
So I have a question.
Yeah.
How much time would it take to write it versus using Raven, you think? If you had to kind of guess.
It's really hard to know. It depends entirely on the task
Yeah.
and the operation.
Like this one, just estimating.
I mean, I could probably randomize the rotations of these if I took about 20 minutes to write it and figure out the math and the workflow of it.
I'm just saying about where AI can save you, let's say 15 to 30 minutes per task. That's a huge deal.
It's a big deal.
Yeah.
And it adds up over time.
Of course.
Yeah. So learning about how these tools think is interesting. Now, I should probably also show you the website for this, which is called Romantic Technology. Romantic.technology or raven.build is the website. You'll notice that Raven stays on top here. You can minimize it if you like. And it's bringing AI power to CAD, right? It's still CAD. We're still drawing in space, but we're leveraging AI to help us with that. So coming back to here, what's it thinking? Still thinking through it. Maybe I should have put it on fast mode.
So
But
what's it saying there?
yeah, it's thinking real hard about what I meant. So what it should do is, because I use the word random, there's going to be a couple inputs that weren't there previously where I can adjust the amount of randomness or things like that. And working intuitively with Raven, you can start to say, well, that's not what I meant. What I meant is this. And it's an iterative process where it will rewrite and re-edit that script pretty interestingly. Figuring it out. It's getting there. Any other questions while it's thinking? Anything else? Yeah.
So is this smart mode a little more accurate? Like if you have more of a technical question, would you recommend the smart mode or the fast mode?
It takes some experimentation to play around to see what works, but I would say that if you're patient, use smart mode. If you're impatient, you need an answer right away, try fast mode. One of the things we learn as designers is that patience is an incredibly valuable skill because not everything happens right away, and architecture is a long form art, right? So we kind of have to be inherently patient. But I suppose I wonder if I change, I haven't even tried this yet. If I change this midstream to fast, I wonder if it'll go any faster. I'm not sure if it can think about that change.
How long have you been using Raven?
Good question. For about 2 months. It's a very new tool. Actually, more like 4 months now that I think about it. But this version only came out about 3 weeks ago.
Does it work with any other parametric modeling software?
There's a program called Dynamo that works natively within Revit.
Yeah.
There isn't a version.
Does Raven work with Dynamo?
There's not a version of Raven for Dynamo. It's purely Grasshopper native right now because Grasshopper is kind of become like an industry standard for very complex geometries and things like that. But you don't have to use it to make complex geometry. It can make pretty much anything. So if you're using, say you're studying a building volume, you want to optimize the rotation of a face of a building, for example. You can use Raven and perhaps Ladybug or another evolutionary solver tool to help you optimize, given a context setting that you're in, that one facade potentially. Now, when I use the word optimize, it's kind of tricky because we can't optimize everything. And data works in a certain way in this Grasshopper land that isn't specific to the physical world really in all cases. So optimize really means I'm narrowing down the parameters that I'm looking at in order to solve something, right? So when you're optimizing something, you're really thinking about, okay, what's the weather data? How do I bring that in? What are the constraints? What do I want to change in terms of a depth or a width or a certain number of parameters? If you have too many parameters, you're either going to break that solver and it's not going to work, or you're going to have return a lot of errors. So the more you can edit down that optimization process to know exactly what you're solving for, the better off you are.
I have a quick question.
Yeah.
Do you guys know what optimize means? Do you have a guess?
Yeah, what is optimization? Anybody?
Efficiency, like taking less steps to do something.
Yeah, that's one way to think about it. What might be another working definition? So efficiency is involved for sure. I would say it also implies an iterative process. So recursive processes or trying things over and over again to find the best result. But fundamentally, you're right, it is about efficiency. It's about finding what's going to give you the result that maybe returns a lower energy use, for example, that returns a lighter structure, for example.
But that reiterative is important though, what he's mentioning, because optimizing is not one thing, it's a process
Yes.
to optimize, right? So it's not just efficiency, it's the optimization process, which is a reiterative you mentioned.
Yes, and there's terms within Grasshopper are specific to Grasshopper in some ways, but there are also broad terms that mean just what they mean, right? A point in space is always going to be a point in space no matter what program you're working in or what reality we're talking about. A point is a point. So the mathematical constructs of those things aren't changing, right? But the way we can describe them can change. So now it's kind of finished. I've added a random rotation to your cubes. I used area to find the center of each cube, generated random angles between 0 and 360 degrees using random and list length, rotated 3D. You can adjust the seat slider to change the random pattern. So what Raven has written here, it might be a little messy, but it is cohesive, and none of these components have turned red or orange, which would indicate that they're not working. So that's a good sign. And you can see over here that we have some kind of rotated cubes looking like they're overlapping. Now, if I minimize Raven for a moment, these nodes are all visible because their visibility is turned on. I'm going to right-click on the canvas and say Preview Off, and then we'll only see our rotated result, which is this last node here. So if I highlight that node, that geometry lives within that node. I can now right-click it, do what's called bake, which means it's going to cook the geometry into the 3D model. Oh, got a bake failure. Never seen that one before. Let's try it again.
It's only when you present.
Maybe it's only when I'm presenting it won't work. But in 95% of cases, this will bake your geometry into the 3D model that you can then render use otherwise, do Boolean operations, do anything you want in Rhino that you would do otherwise. Once that geometry is baked into Rhino, there's no pulling it back into here unless you want to re-reference it, right? So it's no longer live. If it's green, highlighted like this, and you can change the colors, it's no longer this live geometry, it's now kind of cooked, right? So it's no longer the cookie dough, you have the cookie. So that's kind of the basics of really what I wanted to show and answer any questions that anybody has, but we can experiment more. If you guys have a prompt or something that interests you, we could ask Raven what it thinks and try something else. What do you guys think?
I have a question.
Yeah.
When you bake, does it, I have two questions actually. Can you, does it auto set to a specific layer, or can you adjust what layer it bakes into?
Good question. When it bakes, a dialog comes up and you specify which layer you're putting it onto.
Okay.
Good question.
And then the bolded parts in Raven, are those indicating the node that is like the name of that node?
Yes, and I should go into a little bit of kind of some grasshopper basics for that. So you can change the visibility of these objects by going up to display. You can say, don't draw the fancy names, which will change how the icons appear. You can say, I don't want to draw the full names of things. So now it'll just give me abbreviations for the inputs and outputs, for example. But I like the full names because I like to read things. So we're going to see the full names. Let's see, draw nickname overlays. That one maybe isn't functioning right now. I need to update this version of Rhino. But essentially, the interface of this is somewhat mutable. But in general, the information is always moving from left to right. It's always a node-based interaction. So you're telling this information what's kind of going on. And to go into a little bit more Grasshopper basics, if I type panel, if I can spell correctly, this panel is just like a little sticky note. I can take any one of these nodes and plug it into the panel, and it'll tell me what's the output from that node. So here's a component called list length, which I can find from my set of tabs up here, or I can just double click and type in list length, right? And it gives me that node. And let's see what's in there. A value of 78. We have 78 cubes, right? Now if I tell this other node that I want to see what's in there, let's see, let's look at the random node. A whole list of random values, random angles that it's rotating the cubes at, right? If I look at translating those rotations from degrees to radians, which it needs for this rotation tool, you're going to see similar random values that are different in radians, what are called radians, which are different than angles. I'm not going to get into the math of that specifically right now. But then you kind of end up with your node. And then if I plug this panel, for example, into what the result is, you'll see that those are all closed BREP shapes. BREP just means solid.
That means what?
Solid.
Solid.
So that's some of the basics. I hadn't prepared a ton. I thought maybe you guys would have some ideas of something you'd like to see us try in Raven. We could try it out. Yeah.
I have another question.
Sure.
So in that final node, the little arrow pointing down next to some of the words.
Over
Or
here?
not that, the one before that.
Oh, yes.
Yeah, those.
So when I'm looking at data, the data has a structure, what's called a structure. Let's just go full screen in Grasshopper here. So let's plug our geometry into our panel. You'll see a list. The lists always start at 0, which is important to remember because sometimes you need to remove that 0 value in order to have a clean list of 1 through 10 or say something like that. That can get a little bit tricky to manage sometimes, but it's not that hard. Basically that structure of that data, there's also one called, there's so many components, I forget the names. There's another one that will show you, I think it's data tree. Or maybe it's just tree. Or is it param? There is a tool that I'm blanking on the name of. This is why it takes a lot of kind of back and forth. That will show you that data structure itself. I'm just looking at a list of that data in the panel right now. If I use this down arrow, Raven did that by using what's called flatten. Here you can see that check mark. The data's been flattened into one list when it's coming into the node. Okay, which means it loses all of this structure of being in a list of 1, 2, or any data that's in it. It might have just done that as a precaution in case there's any other data in there. Sometimes you got to kind of reverse engineer Raven's logic to understand it. But that flatten command will take the data as a list. If there's sub-lists or things in there, it flattens it all into one list. There's the opposite of flatten called graft, which will take a list and give it structure, and that's called graft. So if I
This is Raven though using Grasshopper.
Raven is a plugin in Grasshopper.
Yeah, but it's basically doing it as if you're doing it manually. It would look like this, right?
Any output from Raven will be a Grasshopper script.
Right.
And
What I'm saying is you can do what you're doing here without Raven.
yes, I could use Raven to do, I could say, you know, show me the data structure. Let's actually try that. And maybe we go into ask mode. Ask, tell me about the data structure of this script. I'm going to learn something about the script that I just wrote, right? Interesting. It's going to think. I have it on fast mode, so it should think relatively quickly. Won't be too, well, it depends on the, this script isn't that complex maybe, so it might get it right. We'll see. And there you are. So I can now read through. The current script creates an array of boxes, and it tells me exactly what it's doing. There's a slight mismatch in the data trees it's telling me I could look at, handled by component modifiers.
What was your prompt for this? What did you say?
Tell me, the original prompt was to rotate randomly the series of cubes.
Tell me, I see it there. Tell me about the data structure.
Yeah, yeah.
That's great.
Now I'm actually in contact with the developers of Raven as of later, mid-fall, I think it was when I got in touch with them. And they're actually working on some pretty interesting evolutions of this tool where it'll eventually have a memory. So you'll be able to go back to your previous prompts, kind of like an OpenAI tool or one of those, to revisit your previous prompts. If I close Raven, I'll lose that prompt. So sometimes I'll just take screenshots and document sometimes what I'm thinking, what I'm doing, so I can recreate it if I want to. But they're expanding this tool very actively. They want metadata of users, so if you're contributing to Raven, it's kind of a cool way to participate in that. And it's not that expensive. I think it's $9 a month. For students, you know, that's not going to break the bank. If you experiment with it for a month and you never use it again, lo and behold, you lost $9.
I like this though. You're able to kind of figure out. You can learn a lot from it this way.
Absolutely.
Yeah.
And just by asking the script, because it's putting in bold what is a Grasshopper term.
Yeah, yeah.
So everything in bold is a term in Grasshopper. Now, I can go through here. It'll tell me all about it. I can keep asking it questions. I can, let me actually open a script that I have from way back when, if I can find it. Let's see. Oh, internet doesn't want to. Here. I went through, this is how many iterations I went through to draw that conical structure that you saw earlier. So let's just open one, maybe version 6 or something like that. This is an example of a script that I was using to generate geometry. There's the model with some cooked or baked geometry that I was experimenting with. And then somewhere in here is the live version. This version of the script might be broken, it might not work, but you can actually group and cluster nodes. So I can move this group around as a group. I can identify that group as the wood profiles, for example, and know what that part of the script does, right? Raven is working on being able to interpret those groups as well. So that's actually pretty useful. You can say, hey, take all the wood profile part of the script and make it do this, right? So that's pretty interesting. This is the whole script altogether. It's kind of a beast. I was learning Grasshopper at this point, so it's not the cleanest script, but it worked. I can ask it. I can ask, let's close Raven and reopen a new session. I can ask Raven in ask mode, can you describe what this script is doing? Like one of the most broad questions you could ask of a math operation, right? But let's see what it does. Can you describe what the script is doing?
So I didn't see the hands go up earlier, but who uses Grasshopper now or have used it?
Anybody?
Okay, good.
Quite a few?
So this is super helpful.
Good.
You can ask a question.
Yeah, I was gonna ask how much of Raven did you use during this process making the shading structure?
This was way before Raven was ever invented.
Oh, so you did
This was back in, I made this back in 2017.
very Very
So this is
cool.
when I was first learning Grasshopper,
Okay.
actually, this script. And it got a lot more complicated. The final result was even twice that size, I think. But here, we have some results of what it thinks about it. The script appears to be a parametric generator of a pavilion structure. I must have put some labels in there that it read, right? Using elliptical profiles and vertical structural members. Here's a breakdown of the logic, and it tells me each kind of group that it knows it can read and what that group is doing. So you can learn about a script that you find online, for example. If someone wrote a script and you're curious how it works, download it, open up Raven and say, what does this script do, right? And it'll start to tell you that story. Now, there's math behind this, but there's more logic than there is math, really, about how data kind of moves. I'm not a super advanced mathematician. I forgot my high school calculus like 10 years ago, you know. But I can do some of that stuff, and I know some of that, right? But this is a great way to pick that math back up and say, oh, this is interesting. How does that really work? And start to reinvest some of that knowledge that you have from maybe your math courses or when you took Calculus 1 or Advanced Algebra or whatever it was. And to say, oh, that's actually useful now. They told me I would never use this, but look here, I'm using it, right? So like the idea that when we pick up these skills, they build on each other. So you can use your skills now with natural language to interface with this. I mean, to me, the idea of like all the world of math and all the world of language like overlapping, it's like, holy cow, right? So this is pretty incredible technology. And the fact that it's coming down the pipeline now, that the developers are seriously seeking user input. There's a Discord channel, I think, for the company. They're really interested in getting a lot of data about how their tool is working because they want to improve it. So that's kind of the download that I had for everybody. But
Having to use Grasshopper in 502 project. 1, 2.
a few.
Can you use Raven with other platforms like Revit or AutoCAD?
If you're exporting out of Rhino, yes. There's not a version of Raven for example, like SketchUp or any other programs. It's native to Rhino and Grasshopper. But you know, when you're developing an initial form or doing a study of something, I would like to start with a sketch. Oh, I forgot. How did I skip this? So this is crazy. Raven can read drawings. Actually, let's do this live. Did anyone want to do a little sketch or a doodle of a form that we could make?
I already
Do
did.
you have a pen? You already got one?
Yeah.
Let's take a photo of it.
Kinda, I mean, I can probably make it better.
No, it's okay. Doesn't have to be good. Here's our sketch. Okay, we'll try and rotate it. Now I can kind of airdrop that to the machine here. Save to files. Desktop. So here we go. Okay, what's your name again?
Alex?
Alex. Here's Alex's sketch. Let's rotate it. Do you want to rotate it a certain way? Did you have an idea?
The long line is the top.
The long line is like this.
Yeah.
Okay. Let's save it. Let's use it as an input for Raven. I'm going to start a new Grasshopper document. And we'll tell the sketch to pop in there. Oh wait, that's a path. Sorry, I got to use the plus button. Is that our sketch? No, that's a rainbow. There it is. And what should we prompt it to do? So we should say, maybe come up with a prompt.
So that was like an idea for like a shade structure. So the top is like just like a long overhead shade, and the side was just like this side.
Like a wall or a...
Yeah, and it was supposed to kind of like just go
Fold
in
it
steps.
in
Like,
steps.
Kind of like a book opening.
Okay.
But each end has to extend to the neck. So like this one, if I extend it, then this line is not short enough, so it would have to
Extend out.
Yeah.
So then this is where the narrative sensibility becomes useful, right? We should develop our skills as writers. Because really what we mean is, hey, I want to describe this. Oh wait, how do I describe it? Oh, skills of a writer, right? So if you can go into that and say, well, it's a shade structure. No, it's a trellis. No, it's a whatever the term is, right? If we can package that prompt and prompt efficiently with that and put it into Raven, let's see what it generates. So let's just say, develop from this sketch a shade structure using polylines. Right? Pretty open, pretty broad. Let's see what it comes up with. You guys want to do fast or smart? Fast? Let's try fast. Let's see what it does.
Let's see how dumb fast is.
Let's see how dumb fast is.
You gotta,
There's the old adage that you can have, what is it? You can have something good or fast but not cheap.
That's right.
Or
One and
two of the three.
Yeah. Well, I don't totally agree with it. You can have all three.
Yeah, I agree. Given enough
Yeah.
time and love.
That's what they don't tell you. Time is also part of that.
It's true.
It's the third dimension.
So let's see what it comes up with here. I bet it's going to be interesting.
So
Let's.
this is part of your 502 project?
I hope so.
How many, I do have a question when we're done with that.
Mhm.
Is doing a curved facade with glass panels,
Yeah, that's a prompt we could write.
so I'm just helping out Steve.
There you go.
Yeah.
Let's write that next. Do you have a sketch or anything that we could look at?
No.
We could use a sketch or we could just use language.
Okay.
Yeah. If you have a drawing or anything, we could use it as a visual.
Doesn't have to be fancy, look what you did, it was just perfect.
You could also.
You can cost it, don't worry.
Just like do a partial, just like a partial.
Yeah, just like a little thumbnail drawing or any kind of like axonometric drawing or anything.
Like plan view or elevation?
Elevation.
Yeah, elevation view.
We're all gonna watch you as you sketch.
Be fast. Don't be smart, be fast.
Be intuitive.
Do you use Grasshopper quite often, like in your, like when, like at the firm that you're at?
Well, in my own practice, I use it kind of as a research tool. I've used it professionally for offices that I've worked for in the past. It's a big time investment to set up a script that's like the Shade Pavilion one that you saw. The principals of the firm I was working for gave me like 6 weeks of research to be able to do that. Because it took me a long time. I was new to Grasshopper. So I kind of went from like intermediate to zero to like intermediate, right? In that span of time. But in that process, they were iterating through the design. They were giving me drawings, like hand drawings of what they wanted. I was working that information. I was Raven. I was working that information into the drawings and into the Grasshopper script, right? But now we have Raven, so we can use like natural language, and it's amazing. And so here it's still thinking. But there's limited use cases at times. Sometimes, like not everything needs to be done in Grasshopper, obviously. But if you have a condition that, back to the word optimization, or if it's a more sculptural form or a more, very detailed facade, for example. I think a lot of facade designers or specialists will use it, things like that. There's also a lot of use cases like in jewelry or sculpture or anything you can imagine that needs complex kind of form making.
Very cool, thank you.
Yeah. So let's see. Action required. I'm unable to place the components because no active Grasshopper document was detected. Now that's strange. Let's copy my prompt and let's reopen. And actually, I'm going to use the work in progress version of Rhino that I have. This is actually Rhino 9. Let's see if it'll work. It's a work in progress version, so you never know if it's going to crash, but let's just try it out. We'll go to new model, Grasshopper.
Someone told me that, like, it was I've never done. I got scared to
Okay, so now we'll open up Raven.
I'm still on 7.
We'll point back to our sketch. And we'll put in our prompt. Develop from this sketch a shade structure using polylines. And let's try fast again. Let's see what it does.
Upload the picture of the building. You can
Push a
maybe
pull
put
in
the
Rhino 7 already.
Yes, the AI will read images. It depends. It's better sometimes with like more simplistic line drawings. Like for example, if you wanted to make a very sculptural building, if you give it that sculptural sketch, it's not really going to know what you mean in terms of the inputs. because it's trying to guess, well, oh, there's a curve over here and a blob over here, and it's going to make something really crazy. But if you can define what I call control geometry, for example, like that in that elliptical tower, there's an ellipse as the control geometry. Everything is based on that ellipse, right? So really what you would want to do is set that control geometry and then work from there towards the form that you want to kind of have happen. But it's a little bit like sculpting with math or something.
So have this geometry in Rhino or Grasshopper first and then?
Just an idea. It could come from a 3D model. It could come from a sketch. It'll read a sketch. So if you have an idea, or even, I mean, if you wrote a long enough prompt and using the correct wording, you could do it entirely with language, theoretically, right? So I have an ellipse on the XY plane. Copy that ellipse vertically by 100 feet. Rotate it, do this. You know, you could use Raven to do that. Yeah. So here it's generating something. Let's see what it's doing. You can set this up any way you like. I like to keep Raven off to the right and see what it comes up with in Rhino space. So here it's iteratively thinking through. It's adding components, thinking about how to best make this sketch. Aha.
Whoa.
There it is, wow.
Interesting.
Okay, okay.
Interesting. So this is where some kind of orientation would help, right? In your sketch, if you say, draw a line at the bottom and say, this is the ground. This is the XY plane. We're looking at it sideways. Now, the next thing would be, this is my form above the XY plane. It always wants a point of reference, similar to how an AI kind of thinks. So there's a starting point, right? What did it do? It made a list length. It kind of broke up this tree structure. We can play with the density of that form in here, the density of the points, right, dynamically. That's pretty cool. Let's try a facade. Who wants to try a facade? We could do,
Is your sketch ready?
do you have your sketch by any chance?
Okay, bring it up.
Might want to add a ground to it.
I did.
Let's go to a new Grasshopper document.
Okay, I'm thinking the top.
Oh,
Like
cool.
a tall
Okay, yeah.
facade with like
Can I use both of them? I'll just get them in one picture.
Go ahead,
There you
yeah.
go. Let's try it.
Okay, let's see.
Thank you. Let's not change the save. Let's save that. Let's send this off to the computer. Save to files. Save. We'll open up Raven. We'll say, let's put it on smart mode, edit mode. Let's add our image, which is 288 there. Should be the right one, right? Yep, there's our sketch. So we're going to try and turn this into a kind of facade. We have, what's nice is we have almost kind of like a sectional drawing, it looks like, and a more of an elevational drawing. Was that the intention?
Yeah.
Is this one kind of a section? Is that more
The
like?
second one I want to scratch, but the top one I was thinking like this glass storefront with like a band.
A band around.
Yeah.
Okay, so that's good. We can use language, right? We can tell Raven, make a band around this facade. Let's see what it does.
What's really cool is that had you not done it, you're ahead of the game now a little bit. I mean, not necessarily to all of you. She's now in the lead.
Now, how would you describe the form of the building in plan? Is it a square in plan, or is
I'm
it
sorry?
the form of that imagined building in plan? What shape is it?
Let's just go square for now.
Square? Okay.
Yeah.
Using the sketch, create a square
Maybe it's a jelly bean.
building.
A jelly bean.
A jelly bean. Oh, let's
Yeah,
do that.
put jelly bean.
Let's do that. Using this sketch, create a jelly bean shaped building
There you go.
and articulate the facade of the building using the input sketch as a guide. Oops, I didn't spell building correctly. I think it can autocorrect too, but you never know. All right, let's see what it does. So because we put it on smart, it might take a moment, but we can field questions or any other thoughts you guys have while we wait. Having to wait 3 minutes for our design to, oh my God, right?
I know, right? Remember the comedian Stephen Wright?
Yeah.
He had a comment he made, is that you stick instant coffee in your microwave and you go back in time. That kind of cool.
I love Stephen Wright. I actually saw him live. Like,
I saw him live at the Amex.
was it? He was in Tucson. I saw him.
Oh, really?
He's so funny.
90 minutes, you slap straight.
He's in one of my favorite movies of all time. Do you guys know the director Jim Jarmusch? Anybody know that name? Jim Jarmusch. He was big in the 70s and 80s in New York, but he still makes movies. And there's a movie called Coffee and Cigarettes.
Oh, I've heard of that movie.
It's a famous
Oh, I
film.
know that movie.
Roberto Benigni is in it. He's a famous Italian actor. And Stephen Wright's in that film, and they're sitting around coffee, having just cigarettes and coffee. And he goes, Stephen Wright's like, he has this kind of down-toned voice. He goes, man, I got to go to the dentist. I really don't want to go. And after about a 10-second pause, Roberto Benigni's character goes, I'll go for you. He goes, really, man, you would do that? And he goes, yeah, I'll go to dentist for you. It's the funniest scene I've ever seen.
You guys gotta watch it.
You got to watch Coffee and Cigarettes.
Yeah, and this is the comedian, Deadpan.
Deadpan
I
stuff.
think he's actually medicated. Look at that.
So let's change our central focus here and see what it comes up with. Sometimes you'll have issues with units, so you want to make sure in general you don't want to work in millimeters usually. So this is like a tiny thing that we're making, but let's see what it does. Where's the jelly bean? There's our jelly bean.
I should rotate it.
It's still thinking through it, so it's going to break a few times before it gets it, but.
So will it like do something if it decides it doesn't work or like automatically remove it?
Usually that's it, trying to figure out the data structure.
Oh, okay.
So it's not really, AI isn't necessarily a conscious entity, but it is thinking about the problem, right? Like in a way, it's problem solving, and part of that problem solving is the math will break occasionally while it's figuring something out,
Okay.
and then it kind of goes through the process. So here we go. We have a surface, we have panels of a surface. Let's zoom in here and see what we got. If I maybe I'll just put a box around this so we can kind of zoom to it better. Okay, there's something. Now we're seeing all the grasshopper geometry. I'm going to take kind of everything in the script other than the result, which should be, this is a geometry preview tool. Let's just take the first maybe 2/3 of the script and hide it to see what it actually is doing with the result. Whoa. That's pretty cool. So what do we have as inputs? What can we mess with? We can mess with frequency. So let's mess with frequency. That's fun. We can mess with the divisions of the panels. It looks like it might be not panelizing it properly. It's probably something with my units that are off. We can mess with the height of the structure. We can mess with the number of steps in the detail of the curvature. So I can take the curve way down in simplicity, for example, or way up in complexity and a more refined curve,
See a little kinetics there.
right?
That's her research.
It's also making for itself reference points, which is interesting. So it has it's naming them 0.4, 5, 3, 1, 2. I don't know why I did that order. And there's some reference points of geometry that it's using to create this. Is it a jelly bean? I don't know. But this is, now you can work through the logic and find out what's wrong and how to fix it. So, you can go through, sometimes you'll get a component that, just for example, I like array. Let's do index. Now, when the index isn't working, it's orange, and I can hover over this little flag. It'll tell me what the problem with that node is. Okay, so input parameter failed to collect data. It's got no inputs. If I plug it into this one, that one's going to break too, because I put no inputs into nothing, right? So if both those components don't work, they're in orange. If something is actually broken in the math, they'll turn red, but orange is an indicator that there's a data problem. So yeah, that's, not exactly your sketch, but you can work with it, right?
You have to go to the left a little bit.
Yeah, what's that?
Go to the left a little bit. No, in the graph.
Oh.
The facade grid glass preview.
Oh, let's turn that on.
What is that?
The facade it was trying to make.
Yeah, see, it didn't really figure out how to panelize that. So what we could do is we could say, oh, interesting surface that you've made here. Let's try and panelize that surface. So we could do, using a plugin called Lunchbox, which is another plugin for Grasshopper, we can use, let's make some quad panels. Actually, it's more interesting. Let's do some skewed quad panels. We'll plug our surface into that and see if it can start to work it out. Now the U and the V, okay, so a little bit of basics of the math of surfaces. Just like space has Z, X, Y, a surface, a mathematical surface, has a U and a V. And that U and the V are the X and the Y of the surface. So if you pop off the surface, you're no longer on the surface, and you are using a W value, which is the Z of a surface. Gets a little more complicated, right? But essentially what you're doing is you're setting the number of points that it's going to construct that panelization with. So if we enter a big number like 85 into our U and into our V as the coordinates of that surface, it'll be a fairly detailed panelization, right?
Now, if you zoom in on that, let's see.
Let's zoom in.
What's the panel size, you think? I mean, can you zoom in on the panel?
Well, this would be one panel right here.
Right there.
Yeah.
Now, does that panel have any identity to it?
It does. I can take these. Let's lower this so the computation isn't so intensive, and then we'll take these panels. The panels come out in A, which is the panel system, and panels B, which is I actually don't know the difference between panels A and panels B, to tell you the truth.
Does it give you a dimension of the panel?
Yeah, you can deconstruct.
So this is important because if you're actually making technical drawings on a skin like this, you want each panel so you can actually build them.
Right, so if I use what's called a deconstruct brep, if I hover over this component, let's make this a little more visible. Deconstruct brep means it'll take any closed object and break it into a number of faces and edges and points. Right, so that's a useful component because basically it's telling you, here's how this thing breaks down. The output is faces as a list, edges as a list, and vertices or points as a list.
See, what I'd like to see, and maybe it has it there, but like each panel gets numbered and it gives me a size for each panel.
You could do that. So let's take an area component. Area will give me the centroid of an object, as well as the either volume or surface area of it. So let's plug the faces into the geometry. You'll see a point appear for the center of each of the panels. Really cool.
Yeah.
And then at the centroid, you could use text, centroid. Did I do that right? No, it's preview text. What is it? Text. Text entity, I think it is. Is it there? It's been a while since I've done a labeling operation. There's a few different text tools. A label? No, it's text. Text on surface. So we'll take a panel. We'll write architecture. We'll plug that in as our text. The font we can set by right-clicking this and setting a font. This will be the height of the text. This will be the depth. This will be the baseline. And this will be the optional base surface for orientation. So I could use the base surface. I could use the baseline for text, which is probably the centroid, I would imagine. Nope, didn't work. What's going on? Data conversion failed from point to curve. So let's ask Raven. Hey, Raven, help me label all the panels in this script in sequential order. So if I get stuck, I don't get frustrated, ask somebody, right? So the tool's there to help you work through when you get stuck.
So we designed a council chambers in Goodyear with a curvy, beautiful plywood ceiling, and each, because it's radial, each panel was unique. We just didn't do Revit, and you'll calculate edge line.
So
You can't build it unless you can give dimensions or something.
you got to know the dimensionality of it. Now there's every single panel. Looks like it's looking at the other panels earlier in the script.
It's got those other ones, so.
It does. It starts to get a little complex, right? Sometimes. But what text is it using here? Here, tag. Oh, it's using tag. So we'll just take this component. The text is the number of the panel. Let's just say we want all the panels to read with the same text, which is just like 1, 2, 3, 4. That'll be our text. And our list will be the text to display, list. Oh, location. I'm sorry. That's the centroid. It's going to think real hard. It might even crash because of the number of panels. Whenever you see the spinning wheel, you know something is amiss. You can hit escape and it'll stop that operation. There's also a plugin called Watchdog.
So you guys know how to use Grasshopper, you know how to use Grasshopper, right?
No.
Define use.
Experiment with.
Yeah.
So the component Watchdog will, if that does operation starts taking too long, you can set a time limit and it'll stop the operation, which is nice so your computer doesn't crash.
When the other one crashes.
Yeah. So that one's called Watchdog. It's pretty handy. A couple websites you should know about if you want to take it down in your notes is Food for Rhino. Food for Rhino is a good site. Tons of plugins, tons of amazing features, amazing things, endless math. And you can experiment with any number of plugins within Grasshopper on that site. It's very useful.
By the way, have you installed the Ladybug tools already? And Grasshopper, Ladybug tools, maybe? No, yeah, please do so. You can find the instruction.
How compatible is Raven
Because we need
with
it for
plugins?
the
How
With
com-
plugins like Grasshopper?
Oh, that's a good point.
Would it recognize it or
so
just
would
like?
you use that?
Yeah,
Okay,
you can actually point to certain plugins. Yeah, good question. So we had a question about can Raven recognize the different plugins within Grasshopper, which is an excellent question.
Try to generate the window worlds.
Generate what?
Window worlds.
Windows.
Windows.
Ring worlds.
Oh, Windows. Oh, yeah, yeah, yeah.
So that is using Ladybug.
Let's try. So within Grasshopper, I can set it to point to a file on my computer. And Jason and I were messing around earlier with Raven, and we downloaded a weather data file. So if I right-click on the file path node, it's just looking for a file on my computer. I'm going to say set one existing file. I'm going to go into my, let's see, Raven. Where did I put it? No, it's in here, documents. Raven Phoenix. So here I have an EPW file.
So remember EPW file is the weather data file.
An EPW file is a weather data file for a certain location. Usually they're at airports. And so now let's try deleting all this and trying an analysis on something. Let's just do Raven using a Ladybug interface or plugin. Create a windrows using the provided node of weather data. Now within Raven, I can open up this little dialog here and say, hey, I want to do, this will just come with standard. I have kind of a research version of this software right now, but this you will see, which any plugin you have in Grasshopper, you can tell it to use that plugin. So I'm going to go to, where's Ladybug here? Oh, I don't have Ladybug in this version of
Okay.
This is the work in progress one.
Okay,
I'm
okay,
sorry.
fine.
But we could do that. So
Okay.
you could tell it, specifically use components from Ladybug,
Yeah.
and it'll generate that,
Okay.
that windrows as well. You can also do it for any kind of data stream,
Yeah.
like psychometric chart, heat, anything that comes with that packet of weather data.
Yes.
Yeah.
Good.
Yeah.
You guys have any questions for Rocky?
Any question?
Any other questions? Yeah.
How do you find out about Raven? Because I feel like that's one thing that I wish there was like some sort of like website to kind of create like what AI programs are kind of coming out to help you with like Revit, Rhino, AutoCAD.
Yeah,
So I'm curious if you have like a website or someone that you kind of look for this information.
No, I'm a serial tinkerer, so I like to tinker, and so I'll just download plugins to see what they do. And I think I must have downloaded Raven when it first came out about 7 months ago, and they actually reached out to me to find if I would help them with some things. So you never know. Yeah. Thank you guys.
Thank you.
You're welcome.